Hello and welcome. In this video we are going to talk about chemical reactions, but we are going to look at yields. Now, yields basically just means how much of a product you obtain when you carry out a chemical reaction, and often we talk in what we call percentage yields, but I'll explain that a bit more in a moment. Now, here are two chemical reactions. We've got calcium carbonate reacts to produce, or under certain conditions, if you heat it, you'll get what's called a thermal decomposition reaction, which you might remember from unit C1. But when you heat calcium carbonate, you will get calcium oxide plus carbon dioxide. And a second reaction over here is one with ammonium chloride, and that will break down to ammonia and hydrogen chloride. Now, you'll notice this strange looking arrow over here. This actually means that the reaction is what we call reversible. That means that the reaction can go in both directions. Ammonia can react with hydrogen chloride to make ammonium chloride, and ammonium chloride can break down to produce ammonia and hydrogen chloride. So this is a reversible reaction, and you do need to know this symbol, you need to know what it means. But in terms of our two reactions here, imagine that we were carrying out this reaction with calcium carbonate to make calcium oxide. This is a very useful product, the calcium oxide. It can be used for a variety of things, but imagine we were making this calcium oxide. We start off with 200 kilograms of calcium carbonate. We end up with 112 kg of calcium oxide. Now, this is what we call the actual maximum theoretical yield. In other words, this is what we would expect as a maximum if everything went perfectly. For this reaction down here, we could say that maybe we start off with 107 grams of ammonium chloride, and we end up with our useful substance, which is well, both of these can be useful, but ammonia, we end up with, say, about 34 grams. And again, that's the maximum theoretical yield, the maximum we would expect under perfect conditions. Now, unfortunately, we don't always get the amount we expect. So this one, for example, you might only get I don't know, 100 kg. Now, there are various reasons why you might not get the complete amount, but if we look at this here, we've got 100 kg when we expected 112. That means we didn't get the maximum amount. We can convert this into a percentage, and we would get an amount of about 89%. So we've only converted 89% of our calcium carbonate into our calcium oxide, and this is our percentage yield. Now, what's the reason why we might get a lower amount than we expect? Well, there's various things that could happen. First one is that some of the product may be lost when separated from the reaction mixture. Now, sometimes when we make a product, it's mixed with other chemicals. So, for example, this is calcium oxide and carbon dioxide. Sometimes these two aren't very easy to separate, these two products, and sometimes you don't get all of the product that you want out, so we don't get the full amount. A separate or a second reason might be that the reaction might be reversible. So in the case of this second reaction here, it's unlikely that we're going to get our full 34 grams of ammonia in this case, because the reaction is reversible. That means it's going to go in the backward direction as well as the forward direction, so it's unlikely that you'll get the full amount that you expect. And the third reason is the reactants might react in ways which are different from what you expect. So, for example, when you react lithium with oxygen in the air, you expect lithium oxide, but sometimes you can get lithium nitride as well, and that's perhaps not what you expected or what you wanted, so you wouldn't get exactly the compound that you wanted from this reaction. But these are three major reasons why you might not get the full amount of product that you expected. For this reaction here, you can also imagine calcium oxide is a powder and calcium carbonate is powdered before you carry out this reaction, so you can imagine if you spill some of that or lose some of that, or it's not all collected carefully, you won't get the full amount either. So there are other possible reasons as well, but these are the three key ones that you should be able to use and apply to your chemistry understanding. Okay, now the next section we're doing is for the higher tier only, and what you should be able to do is actually calculate these percentage yields. So I told you what the percentage yield, or gave you an example of a percentage yield here, but you should actually be able to calculate these for the higher tier paper. So let's have a look at this reaction here. In fact, let's just practice something we've been doing in the past, which is our reacting mass calculations. Imagine I've got 200 grams of this. How much calcium oxide am I expecting to make? Well, if we look at our relative formula masses for this, for calcium carbonate, it's a relative atomic mass for calcium is 40, for carbon it's 12, for oxygen it's 16, but remember there's 3 oxygens there, so we end up with 100 as a relative formula mass. So we can put that here. That's the relative formula mass there. And for calcium oxide, that would be 40, and for oxygen it's 16, so that would be 56. So we can use this to calculate our expected amount in grams. 100 goes to 56, so 200 would go to 112. So that is our maximum theoretical amount that we expect. So if that's what we expect 112 grams of calcium oxide, but imagine we only get 108. Now you should be able to give reasons why we've only possibly got 108, and that's related to the last slide, but also you should be able to calculate what the percentage yield is, and the way we do that is we use this formula here, and it's reasonably straightforward if you think about it. It's the amount that we've actually produced, in this case it's 108, over the maximum amount possible, or the maximum theoretical yield that we expect from doing our calculation. So the maximum amount possible in this case is 112. That's our maximum theoretical yield, but we only actually got 108. So what we can do is just put our 108, that's the amount produced, divided by the 112, which is our maximum theoretical yield, and multiply all that by 100. So percentage yield is 108 over 112 times 100, and that answer is 96.4%. That's still a pretty good yield, but you can see it's not 100% as we would hope for, and you should again be able to say reasons why it's not possibly 100%. You should also be able to calculate these percentage yields from amounts given in an exam, and that's for the higher tier. But that's about me done for this video. Thanks for watching, and I'll see you again soon.